Okay, Juggernaut. A lot of people didn't know we were invested. Some people did. We've been invested in this for a while, probably a little over 2 years, I think 2.5 years now. And it was all around one particular target, Midas. And we're going to talk about that. They didn't drill Midas 2 years ago or even last year, but they are this year. They did a lot of field work, geophysical work and stuff that has prepared them targets at Midas. And I'm going to talk about this. Let's go to the next slide. You can see where it's located here. I got two pink arrows over there on the far right-hand side. It's near Terrace, BC, so it's a pretty darn good location. Guys at the drill rig can order from Domino's Pizza and have it flown up when the next helicopter lift comes up. Okay, this is not super remote. So Midas is the red polygon down there in the lower right, but there's another project called Empire that's northeast of Terrace. I'll talk about briefly as well. I think it's a very, very interesting project. Let's go to the next slide. Now, we are out of the Golden Triangle. In fact, Terrace, a little bit north of Terrace, up at Stewart, that's the southern terminus of the Golden Triangle as it's defined today. But really, the geology of this region is very similar to what we see in the Golden Triangle. Okay, we're in this basin, this Balger Basin that becomes kind of morphs into the Nechako Basin to the south, but it's all the same type of rocks. Okay, so the geology that is prolific up in the Golden Triangle, you can see on the left-hand side up the top there, that is equally true for down here around Terrace. Okay, so equal prospectivity, but I think people have, we'll call it, not focused so much effort here. I think it's unjustified. I think there's a huge potential in this region. Okay, so we're going to talk about the Midas property. This King Solomon Zone is one of two zones. Really, it's just one big system. But King Solomon Zone is highlighted on the image on the right. But there's another zone called Kokomo. It's very nearby. And they collectively constitute this exceptional VMS target. Let's go to the next slide. Okay, what is a VMS system? Well, these are submarine systems. They form on the seafloor. Hot waters circulate down. They get heated by magmas underneath the ocean floor, and they pull metal out of those rocks, and then they bring them back up to surface where they form these wonderful sulfide deposits, often rich in copper, zinc, lead, but precious metal sometimes too. And in this case, the King Solomon target here is absolutely hands down a precious metal rich example of a VMS system. All right, I'm not going to take a lot of time. If you want to research VMS, it stands for volcanogenic or volcanic massive sulfide deposits. Okay, Google that, spend the weekend reading up on it. But this is what these things look like when they form on the seafloor. It's a cross-sectional view of how they form. Let's go to the next slide. Okay, so you can see here at the Midas property, at the King Solomon Zone, there's an extensive footprint of gossenous outcrops. So gossan is a iron oxide staining you get when sulfides weather. And the sulfides are often associated with mineralization, precious metals and base metals and stuff. So these orange outcrops, this kind of bleaching that you see, kind of a yellow cast to the rocks, and then the bright red and orange stains that you see all over the rocks, those are a telltale sign that there's a big, big system here. And that happens to be in a geologic environment that is conducive for VMS deposits. In other words, it's seafloor rocks that we would have expected to form at the seafloor and are stratified. Now, in this case, they've been squished up. I mean, think about it. If you have to take a VMS deposit from the seafloor and bring it all the way up onto the continent, it's got to go through a lot of deformation, like a lot of squeezing and pushing and shoving and faulting, and that's what's happened to these rocks. Okay, so this blob of rock that you see in the picture here has literally been thrust up onto the North American continent. The rocks have been folded. Okay, so you can actually get VMS occurring in sinuous folding and stuff like that. And that's probably the case here, and I'll show you why in a minute. Let's go to the next slide. By the way, the Kokomo outcrop that Layla is standing on here, this was discovered very recently. They sampled it, got 9+ grams. There was a higher grade assay from this as well, but you can see why was this not tackled earlier? Because quite frankly, like a lot of things up north, this has just recently been exhumed or brought to light again because the ice is melting. The glaciers, the snow caps are melting, and you can actually see these rocks now. Okay, so the team there at Juggernaut, which has a lot of overlap with Goliath, by the way, they found these outcrops. They channel sampled them. This is a saw cut, and they got very, very good results. I looked at the rock. It is very texturally, mineralogically, everything tells me VMS, where all systems go here. Let's go to the next slide. Okay, this is a bit of a summary of the King Solomon Zone, and I don't want to go through every detail here other than to draw you down to the fact this was drilled in 2018. Now, it was done kind of before they had a lot of the basic work done. In other words, they came in, drilled some holes quickly, and they did hit mineralization. But because they didn't have full geophysical data and other stuff, it was probably not quite targeted right. But nonetheless, it hit some interesting values, including 6.85 gram per ton gold over 9 meters. That's not a bad intercept, guys. And then 0.55, bit lower grade, but 0.55 gram over 35 meters. Tells us there's a big system here. There was a lot of base metal accompanying that as well, including, in particular, zinc in this case. Let's go to the next slide. Okay, now what has the company done? They've done a lot of geophysical work, including IP resistivity, and what we see here is some of the data from that. This is a chargeability section. Okay, so it's a cross section through the ground, and it shows us in the subsurface where there are rocks that are electrically chargeable. Okay, when they pump the electricity in the ground, these particular rocks, which probably have sulfide minerals, get electrically charged. So they kind of like soak up the electricity like a sponge. Okay, and they are highlighted by the brighter, warmer colors that you see here. Okay, there are a lot of anomalies below the surface there that have not been drill tested yet. Okay, so this is what I mean. These are what I would call the bona fide targets that we got to go pound away at here with some drill holes. Now, notice they've named their drill pad SK1. Why did they do that? Just to be cute? No, well, kind of. Okay, they see this as an SK Creek analog, so they name their drill pads SK and VG and clever names like this. Anyway, just don't confuse this. This is not SK Creek. Okay, this is miles and miles away, but the geology is very similar and the potential is very similar as well. Okay, this is the target I like the most in this company. They're going to drill it this year. I'm very excited to see this first test. Okay, this is one section. Let's go to the next slide. You'll see another section line here, equally compelling chargeable anomalies. Again, several drill holes will test each one of these. Okay, so we're looking at a robust drill program that's going to commence any day now up at, in fact, the geologist that was going down there to run this program, I think is on site right now, and they will be drilling here shortly. This is a roll of the dice, but a very, very big one for this company. Could go, this could be one of these sleeper stories where they go up there, drill, make a big discovery, and they go from, pennies to, hopefully a lot more, maybe dollars. They're very tightly held. We do have a big position in a very short period of time. So we're very, very hopeful about the potential of this. Now, before we leave, go to the next slide. Okay, I want to talk about that Empire project. This one is the one northeast of Terrace. It is a bit of a headbang. When I first saw the data for this, what on earth is this? Some incredible sample results. Extremely high-grade silver, like percentage level silver, and also percentages of copper, like 27% copper. And I'm thinking, what on earth is this? Is this is it sedimentary copper system or something? No, I'm gonna when before I went here, I didn't have my mind made up. Okay, I've seen samples and stuff, just didn't have my mind made up, but now I do. I'll show you what. Okay, so these are the targets there. Metallica Zone in particular is where a lot of the drilling is going to be targeted this year. It's a small program, but I think a well-justified early stage program. Now, what are these high-grade results from? Let's go to the next slide. You can see here a close-up of that Metallica Zone, showing where samples were taken, some of the values that came from it. There is gold in here as well as silver and copper. Okay, so these are exceptionally rich samples. They are literally on a cliff face here. Okay, I mean, this is crazy stuff, but this thing is, these are veins outcropping. And I'll tell you, Lele and his team, they're Swiss, or Lele is, and he knows how to climb mountains. And that's about the only kind of guy that you want on a project like this. I would not do it, guys. Like I'm looking at that and I'm like, no, my fat ass is gonna fall down that hill. we're not landing there, guys. So anyway, exceptional results. I mean, look at that. You got 2.26% silver down there towards the bottom. That top one in yellow, 0.64% silver. I mean, these are crazy numbers. What are they? Let's go to the next slide. These photos in the next slide show you the samples they took. Okay, very high grade copper, very, very high grade of copper along with silver and a bit of gold. Okay, but they're veins. They're relatively narrow. They're maybe up to a meter thick or so, but they're just absolutely stinking rich with metal. What they remind me of, the mineralogy, just solid copper minerals like bornite and chalcocite and other wonderful copper-rich metals. They remind me of the veins I've seen with certain porphyry deposits around the world, like Butte, Montana. Okay, at Butte, Montana, they had very similar veins to this, where you get hypogene, super high grade. In fact, I got a piece of one of these type of veins somewhere. It's probably in my office here, and I should have brought it up, but it's solid bornite with blades of silver going through. It's just amazing stuff. This is the kind of stuff that you see at Butte, Montana. Now, what does it mean? It probably means these veins are coming off of an intrusion. Okay, and so when we're flying around, I wanted to see what the geology looked like. So I asked them to do several passes. Let's go to the next slide. And what I saw was fairly compelling. Okay, what are we looking at here? Well, look down there at that big patch of kind of bluish green rock. Okay, you say, well, bluish, okay, big deal. Bluish green rock. Why would it be bluish green? Because of hydrothermal alteration. Okay, you can get what we call propylitic alteration, which is a bit of a distal type alteration around a porphyry system. And I think what I'm seeing here is propylitic alteration that is around something that's buried inside this mountain underneath where these high-grade samples came from. In fact, the high-grade samples came from this kind of central knob in this photograph here. Okay, now the other thing that compels me is the fact that you see dikes. See the big white thing going down the middle, and then it's kind of fault offset, and there's another bit of it up in the upper right. That's a big dike of some kind of feldspar porphyry. There's your porphyry, okay? Yes, that dike came up from some mothership down at depth. And then you see these little black dikes. They're kind of dark gray dikes crisscrossing at a right angle to that. Look, those are very important too. Those look like mafic dikes, like really juicy dikes that you would find with a magma system, a big magma system that had come up here. So we see evidence of a porphyry. We see the alteration that's likely pointing to a porphyry. Let's go to the next slide. And then as we flew up and around the corner, lo and behold, more dikes, huge swath of dikes. It tells me there's a bigger intrusion down at depth. The other thing I notice here is bleaching red. Okay, so you see the dark black rocks in this area turn a bright red. I think that's an expression of alteration from a hydrothermal system of buried porphyry down there. Okay, so the Metallica Zone, very interested, and quite frankly, if the company, they're going to do shallow drilling this year, don't get me wrong. Okay, and that's fine. I don't have any problem with that. But if the company does a bit of geophysics and some other work, I think they can define a heck of a porphyry target here that could be tested, say, next year. All right.